Good afternoon and welcome everyone to the 10th installment of the Senior Leadership Insights series sponsored by the Graduate School. The series was created and developed by a group of volunteers from the Graduate School's Board of Visitors, some of whom may be joining us here today. My name is Melissa Bostrom and I am the Assistant Dean for Graduate Student Professional Development in the Graduate School. To make the most of our very focused time together today, I'll address a few logistics up front. We'll begin the conversation with 4 key questions, and after that, we'll welcome your questions. If you'd like to speak, you can use the raise hand option accessible through the reactions button in the lower right corner of your Zoom window. For the students who are joining us, I especially encourage you to ask a question on video or audio after we go through the 4 key questions at the beginning. So the first 3 students who ask questions live as part of the conversation today will receive a Duke Dining gift card valued at $15. I'll note that this session is being recorded, so if you prefer not to appear in the recording, please keep your video muted and you're welcome to share your questions in the chat. So with those details out of the way, I'd like now to briefly introduce Ellery Jones, who is a Ph.D. candidate in biomedical engineering and senior OTC fellow in the Duke Office of Technology and Commercialization. Last summer, she completed an internship in genome and biomarker sciences with Merck's office in the Bay Area. At Duke, her areas of research focus on utilizing tissue-engineered blood vessels to recapitulate the pathological features and progression of cardiovascular diseases in Professor George Trusky's lab. She received her Bachelor of Science degree in biomedical engineering from the University of Miami. So Ellery, I'm going to turn things over to you to introduce our special guest today, Mr. Darryl Webster.
Of course. Thank you so much for the intro, Melissa. So our guest today, Darryl Webster, is a senior executive and advisor to life sciences companies, providing strategic guidance and operational expertise to biotech companies and their boards. He has over 30 years of global corporate experience across human, animal, and plant applications, and is currently an advisor to Trampoline Pharma, Inc. Mr. Webster was previously the Senior Vice President of Intellectual Property Counsel at Precision, Inc., formerly Intrexon Corporation, where he served as an officer and part of the management team during the company's IPO. During his 10-year tenure, the firm employed diverse engineered DNA systems to improve performance in human therapeutics, protein production, industrial enzymes, and ag bio. And he held interests in therapeutics and therapeutic platforms. Prior to Precision, Mr. Webster was in-house patent counsel for Wyeth Pharmaceuticals, which is now Pfizer, as well as for Allied Signal Inc., which is now Honeywell. At these organizations, he worked on products such as Enbrel, infused bone graft, CFC replacements, and pneumococcal vaccines. As a member of the American Intellectual Property Law Association, he received a JD from the University of Maryland and a bachelor's degree in economics and chemistry from Duke University as a Reginaldo Howard Scholar. He also served on the Trinity College of Arts and Sciences Board of Visitors from 2006 to 2012, and on that board's undergraduate life committee as well. And he has been a member of the Graduate School's Board of Visitors since 2016. So it's a pleasure to welcome Darryl Webster back to Duke virtually for today's conversation.
Thanks for having me. It's a pleasure to be with you.
Of course. So we're going to start off with a couple questions about your career before we open it up to the audience. So the first is, tell us about your background and what was your path to your current role?
So as you noted in the background, I was a chem major and an econ major. Thought about doing things in business, but wanted to pursue my science interests. So we had a chem major with a biological specialization, and I was able to do some research my senior year as an undergrad. And from there, I was going to think about doing business, maybe business school, law school, spoke to a lot of people and decided basically on law, thinking things like FDA, patent law, et cetera. In full confession, one of my big brothers in the chemistry group ended up going to work for a patent firm. So I actually had a lot of access to patent people that he knew and firms, and it kind of grew from there. And I did a lot of those soul searching interviews with people before I chose law school. And that's kind of how it all got started. And I guess when I was in my first year of law school, I got a job at a patent firm. And when I graduated in 82, there weren't really great jobs. The market was really bad. So when I sent out about 8 resumes and I got 3 callbacks, I was pretty impressed that, hey, there's maybe something to this patent stuff. Maybe I can get a job. And sure enough, I did. And that's where it started, summer of 84 as a law clerk and working in a patent firm. And almost everything I did had to deal with technology for that. Well, it was the first summer, and then I continued with the firm through law school. But that's really how it, by chance got started. If my big brother had gone to med school, maybe I had gone to med school, I don't know. But it worked out. I think I was still pursuing the interest of some kind of business or law and technology, and that was kind of the fundamental interest from when I started. And then where does that lead to today? It doesn't change. The experiences changes. They build. You do things across the oceans, all over the place, in different technologies, and again, that drives the interest. And from that, you work with a lot of different people, personalities, cultures, etc. Always trying to move the ball forward for whichever program or company you're working for. So maybe responsibilities may change. Technology obviously changes, but it's the same role of technology in business or technology in law. The common theme that keeps me interested.
That sounds great. Thank you. So our next question is, you worked in a number of very different industries, from Allied Signal, which is now Honeywell International, and Wyeth to Precision, new technologies that span electrofluorinating agents, bone grafts, herbicide-resistant crops, as well as in the biopharmaceutical industry. So all these fields are obviously very diverse, but what did those experiences have in common when it came to your role?
They're all on the learning path, I guess. I probably would have stayed at Honeywell, except we went through a downturn where we were laying off about 15%, and that meant 15% more work for the people there. And I was working hard, learning, but I said, well, I only do a part of what I want to do here. I did more pharmaceutical work in the law firm, and I said, maybe I want to go to more biotech. I did some industrial biotech with industrial proteins, some bioremediation, and obviously the electrofluorinating agents were related to pharmaceuticals, but it wasn't full time. And I got a job in a corporate group where we actually were assigned to do biotech for the company across technologies. So animal, plant, human vaccines. So with that opportunity, I took it, and things, changed from there. There were a couple mergers in there that changed technology assignments for me. But one of the, I guess, more interesting ones, more complex ones, was the herbicide-resistant crops, because there were none. That was about the time that they were being introduced, mid-90s. So even understanding the business plan, how our plan different from Monsanto, who was starting to do Roundup Ready crops, total different dynamics. Ellery, you probably know, when you do your market evaluations for the fellows group, you're looking at justifications, you're looking at what the hurdles are, et cetera, but you may be looking within a certain area where there's things that have come before. With herbicide-resistant crops, it's a completely different situation, because the crop itself doesn't replace all the inputs that go into an acre of growing a crop. So that was, again, complex for everybody in the room, whether you were in marketing, science side, or actually the business side. And so that was one of the more challenging ones, because they're trying to figure out, what should patents look like, what was Monsanto doing in their patents, and figuring out how to distribute the technology.
I know, yeah, I found that's kind of the biggest challenge when you're approaching an area or a technology that's very, very new, is it can kind of seem like unlimited or limitless, and it's kind of unknown what all the risks are, and it's kind of unknown where you're going to have those hurdles without a reference point. So that's really cool that you got to kind of be at the frontier of that new technology. So our next question is, in your work, you've encountered many scientists and engineers with graduate training. In your experience, beyond strong research skills, what makes those colleagues effective in an industry setting?
Yeah, you got to remember, I came along before the world of internet. So people and ways to communicate have changed favorably as we sit here today. But it has more of an emphasis today. It's a skill that has to be practiced, and actually, part of what you want to do with other people is part of your ability to do Zooms, etc., and communicate. It's so amazing to have that tool to be able to be in front of someone relatively quickly to work through issues. We did a lot of these things by phone, and that was fine. But again, we were pretty much on the site most of the time. But in global companies, you're not always going to be there all the time. So you have to develop your communication skills across cultures, across technologies. But the best thing is to understand what you want to bring to the table. And you shouldn't ever be shy about it, because questions come from everybody, and one question leads to the next solution, whether it came from you or someone else. So that's the one thing, is figure out what your interest is, what you value yourself as contributing, and pursue that.
I think that's great advice. I think that's kind of similar to what I've heard from other industry experts. Is a lot of times in academic science, we're used to saying like, we did this, my lab did this. And a lot of times we have to train ourselves to really take ownership of our accomplishments and our skills, to say, I can do this and I'm interested in this. So that's, I think, kind of a mindset shift that a lot of people have to take into consideration as well.
And, you can always try to get prepared by, using a colleague or someone else. The best thing to do is run it by someone else. They'll try to think of things that you should either present, or what other things to consider, because you do want to bring something to the table.
Mm-hmm. Thank you. So our last question that we have for you is, what can students who would like to work in this field or explore it further do to prepare?
Other than the fellows program that you're currently in, there's so many things. Like, I think of what technology you're interested in. If there's a technology you're interested in, pretty easy to go at the U.S. Patent Office or even Google Patents and look at a couple patents, look at how they're set up, look at some of the data that's in there, look at the companies. I would say one thing to do, I did it recently. I just searched Moderna and patents. I think I might have put vaccine in there, and it pops up, and actually the Moderna site itself pops up and lists a few patents, and you can see quite quickly that there's a lot of different things related to that, whether it's lipophilic approaches, things like that, or whether it's an actual mutation in the RNA. You can see that quite quickly, and you can do that for a lot of different technologies, but my suggestion is pick one that you're interested in for some reason. And that's kind of an initial thought. And then the other thing is to think about what you have as an interest. Do you want to go to law school? Do you want to go work in a finance group, in a venture group? All those are wonderful possibilities for the tech savvy people coming out of these programs at Duke, and they're quite exciting, actually. If you think about it, if you work for a venture group, you're going to do so many different diligences on so many different technologies, meeting so many different researchers from different companies. It's one of the things that's truly interesting today, and very, very, very diverse.
Thank you. Yeah, I know a lot of people that I have spoken with, when they start to think about if they want to protect their own research, a lot of times they think they kind of have to jump in with everything that they see in a fully formed patent. And they're like, okay, I need all this data ready. And a lot of people, they think they need to be more prepared than they are, I think. And a lot of times you can just kind of go to whatever technology transfer office you're working with an idea, and you can kind of have like a living document, and they can help you decide like what is going to be sufficient to get data to submit for a patent application and stuff like that. So I think definitely that was something that I started to look at in the beginning, and I got overwhelmed, but I think that there are really good resources, especially within the university setting, to kind of get input on what you would need to put in a patent application moving forward if you're interested in patenting your own work as well.
Yeah, definitely the tech transfer office can help you if you're looking at inventions and what to do, or how you might start to be more educated or prepare a better invention record for them. They can give you great hints. I don't think there's an easy way to walk into the world of patents.
Yeah.
It's different. You can find a lot of complex cooking recipes, but your first couple months in patents is usually, eye-opening. It's just a kind of a different world. But the main thing I tell people to focus on is, what are you looking at? What are you accomplishing? What is the difference between your technology? Why did you try this approach? And those answers kind of lead to why something may be inventive, or what the crucial part of what you're going to search to find out whether it's an advancement or not over things that have been done before. But I try to focus on the difference. I don't ask people, okay, why is this an invention? That doesn't really work that well for anybody. And it's not, it can cover up some of the things. People want us making an invention by talking about it in a certain way, or just get back to the basic science of what's different, why is it better, what can you do with it? Those questions those don't change.
That's great advice. Thank you. All right, and I think that is the end of our prepared question list for you. So I think at this point, we can open it up to the chat or to anybody in the audience who wants to jump in and ask any questions.
Great, thanks so much, Ellery. So just a quick reminder for anyone who just joined us, you can use the raise hand button under the reactions option on your toolbar and let us know that you'd like to speak. And if you prefer not to appear on the recording, you can pose your question in the chat. Ellery, I know you had a question for Darryl. Did you feel like you got that answered just now, or was there anything you wanted to elaborate on?
Yeah, sure. I did have a question for you more about kind of how can we define intellectual property as graduate students, if that's what we're interested in pursuing. So yeah, my question was, a lot of times academic researchers are under the impression that their work may not qualify as intellectual property because they're not necessarily creating a new invention or a product, but they are working on improving research methodologies or improving research processes, or making basic science discoveries about biological or chemical processes. So to what extent can new methodologies or discoveries about biological and chemical processes be protected as IP?
Yeah, I mean, one of the things is when you get into some of the biological processes, you get into the area that they call research tools. Research tools are patentable. It's just whether you can enforce them and what's the value. But they are patentable, and they are inventions. And I don't want to go down, explaining the research tool issue. It still comes back to, what could you use it for outside of the current setting? In other words, what would a commercial company want to do with it? And if you have an answer that they can do something with it, then it's probably giving you an inkling that it's probably worthwhile. But processes, there's so many different things that come up that you can actually patent. And I don't want the inventor or the grad student or others to feel that, oh, I'm not making a patent, I'm not making an invention. it really comes down to what is different about it, and what is the performance that you get out of it? What's the accomplishment? That's really what you need to be asking yourself. And then you can go to the tech transfer and say, I have this. Does the university have a policy about pursuing these things or not pursuing them? Here's what I think you could use it for, because it does have a certain level of improved performance, right? Sometimes the biggest thing is just improved purity. One of the first more complicated things that I learned coming along in patent was we made polymers that go into aircraft, and they have what they call a char rate. For these purposes, call it a burn rate. And so if you're sitting in an airplane, you want the char rate to be pretty high if something happens. And it came down to they actually created a material, same polymer, but through the process, the char rate was 20-30% improved. And it really came down to how pure you could get it. And previous processes were not that pure. And it was actually huge invention because the material was well sought after by industry. So like I said, what's the improvement? What's the purpose? Why do you think it has value? And bring that to the tech transfer. I don't ever want people to sit there with technology that's good and say, well, I'm not sure it's inventive. That's for someone else to figure out some days.
Yeah, I've seen people really struggle with that a lot, where, you know, as engineers or as scientists, a lot of people are working on improving processes every day, and they might not necessarily realize, like, oh, you know, the way that, or this new method that I've come to make to streamline my own thesis work could also be applied to other research labs or to other researchers outside my field, or even industry. So I think that's a really good thing for bench scientists to think about, and other people who are coming up with new methodologies, is that if it's working for you, it could work for somebody else. And that's definitely a really exciting path that someone could explore.
Yeah, and one of the things also, and I tell that story, I think I was certainly out of law school a couple of years, and I'd been a law clerk. And I kind of was looking at the patent sideways. Looks like the same polymer, but it's not the same patent. So I actually, walked into my boss's office at the time, said, maybe you can walk me through this one. So that's what I mean. I don't want someone, I had a few years experience at the time, and even it wasn't readily apparent to me. And there are other reasons, that I might have doubted it for just technology reasons and some legal reasons, but still on the surface, it wasn't readily apparent.
Great, thank you.
Sure.
So thank you so much, Ellery, for kicking us off with the open questions segment. I want now to encourage folks who are on the call with us to go ahead and take advantage of the chance to ask a question of an intellectual property expert today. Go ahead and use that raise hand function if you'd like to jump in live, or post your question in the chat and we can share it in the conversation.
And then while we're waiting, I think we had another question come in through the survey.
Yes, great point, Ellery. So we did have someone ask, how can you really create a rapid trajectory upward in your career in intellectual property as you're starting out? What kinds of traits or behaviors or practices, Darryl, have you seen for people who really kind of take off in this career field?
Yeah, I think it's a desire to submerge yourself in something completely new and do as many things as you can once you get in. As far as preparing yourself, I would say take advantage of, if you can, the fellows group or tech transfer. If there's even something you could learn about your own lab. Maybe there's some technology that you've seen there that's come out of there. You want to understand it from a patent side. Maybe there's someone on campus that can help you. Maybe even the inventor themselves can tell you a little bit about the background of it. The other thing is if you're at the different meetings or you have, let's say, scientific authors that you're following for things of just interest, contacting the author, asking them about the particular technology and whether they, pursued patents and why or why not. If they're in a university setting, they'll explain it to you. And sometimes even within the industry, they'll give you some basics about what they did. But just tell people that you're interested in it and, possibly attend even some seminars. You can look at top law firms, give you a list if you want, but they do continuing education of things all the time. And you can even listen in for things that might be more of an intro on different topics. You're going to run the gambit of topics in the world of patents. You're going to have regulatory for sure across the board and a lot of different indications. You will have antitrust. Like I said, venture analysis is another one. You can look at some of the venture firms and look at the companies that they're interested in, how many different companies they may be invested in, and it may be a technology or a name you're aware of. But that's probably a way to do it and see who's active in the area. Look and see for a company that might be interesting, a small company, it makes an announcement that they raise money. Take a look at them. There are announcements all the time, and you'll find that's where you find out that right now you see so many different technology things. I know people want to say we might be in a recession, et cetera, but years ago, people committed to some smaller companies and they're still committed to them. And they continue to raise money and push technology along. So within those, you can see either their patents or just see their technology and see, which firm may have some interest for you. Some do early stage, some do middle to late stage investing, but it is all for the most part in some form of technology. Some people will maybe do food chains and things like that, but there are lots and lots of companies investing in technology, and it's a way to learn about some of the new things coming about and develop your interest for technology. And maybe it's not in a new one. Maybe it's somebody like a Moderna. And again, that's a wonderful way to start to look at things. Which vaccine did you take, and see if you can find the patents on it and go from it that way. But start to expose yourself to the technology either within your lab or within your group or by your advisor, by your dean. You can look at it, internally, use those resources, but then start to expand on technology you're interested in, look at third parties, and send a note to somebody if they're the contact author if you have a question. I think it's just starting to create your own approach to how you want to look at technologies.
I think that's great advice. And I think I've definitely seen the same thing. We're just kind of having an innate curiosity about, why is this a successful patent, or why did they choose to pursue this? And just kind of having a curiosity about, what technologies are being patented and what direction is the field going in, and stuff like that is really a good guiding light to try to figure out what you're interested in. And then we have one last question from Susanna in the chat. So Susanna asks, what is the next frontier of patent law, and are there any big new questions in the field of patent law?
Okay. Meta world of research, I don't know. The next big area, I have to think about that one because it seems like we have a new nuance just about every couple of years. There's something that pushes the envelope. We've had certain things in the diagnostic area that were deemed not patentable. Certain things in the computer area that were deemed, not patentable, and then they were deemed patentable in certain situations. So I think as we move forward and technology moves forward, you will see a change. That's just the nature of it, that patent law will probably not lead ahead of the technology development, but as it develops, it almost commands it. A certain amount of things are going to change. We really didn't have antibody claims, when I came along. There wasn't much to that. I think one of the first antibody textbooks was from 1985. So a lot of people just learning it at that time. And, look where you are today. And so the same thing might be true if you look at some of the engineering of cells. How do you deliver? And will you eventually maybe remove some of the manufacturing that's done across the globe as you are able to get that active ingredient or that cell to make it on its own within the body? And that'll raise 3 zillion issues ethically, but it'll also raise some patent issues.
I think that's one of the most exciting things about the field, is that it's kind of constantly evolving as new technology and new discoveries are being made. So it's really fun if you're kind of interested in continuously teaching yourself about new things and staying on top of the latest science and technology.
And I think the interesting part when you go down there is that there's a technology piece that you have to keep up to date with, and there's a legal piece you have to keep up with. And again, it's across the board. You can do it within the US, but a lot of programs are global, especially your biopharma and your pharma. Those are normally global programs. And so you'll have to work with colleagues in Europe to develop a little bit of understanding of patent law there, a little understanding of regulatory requirements there. So it does become quite an evolving amount of information and knowledge that you gain, and it's pretty interesting along the way.
Well, I think that is the perfect note of continual curiosity and learning to wrap up the conversation today. Thank you so much to our audience for joining us. It has been a delight to feature Darryl Webster in this conversation, and hearty thanks to Ellery Jones for conducting the interview with so much energy and enthusiasm. So we look forward to seeing many of you for future events in the Senior Leadership Insights series. We'll take a pause during the summer, and we'll be resuming these conversations next fall. Good afternoon to everyone, and take good care.